Alright, here we're checking the insertion loss of this circulator that I have here. I've already gone ahead and normalized the cable, one of the cables, this guy right here, between here and here, normalizing with these adapters and this cable. So this loss figure that we see right here is the loss of the circulator and this cable. So this is, right now we're checking the transmit path, transmitting out of this line, going across here, and then coming back here, and we're losing somewhere between 0.76 and 1.2 dB. For a transmit path, or hell, even for a receive path, that's pretty much nothing. So let me switch around these cables and we'll check what our return losses, or sorry, our insertion losses going in on the receive path. Alright, now I got the circulator set up as if we are using it on a receive path here. So this line we're transmitting down here, it's going in here, and then out this line. And again, we got a very similar figure, same figure again, neg 1.2 dB insertion loss when we have it set up for the receive path. Alright, now we got it set up with the preamp. So we're generating down this line into the preamp, out of the preamp into the circulator, out of the circulator back into the 8920. So how we basically have this set up, this right here, think of your miner would be right here, your transmit antenna would be on this line, and then your receive antenna would be hooked up right here. Receive antenna, preamp, circulator, miner. So right now we're generating at neg 90 and we're receiving in at neg 67. So that means right now we have a gain of about 23 dB using the preamp. And now you see this line, we're in track generator mode, so we got a pretty steady line going across here. You'll notice when I change this to a weaker signal, you'll still see we have about 20 to 23 dB worth of gain on the preamp. However, you're going to notice the lines get a lot more squiggly, which means we're basically going to have a lot more noise. So let's crank this down to about neg 100. You can tell we're still about neg 20 or so dB of gain. You can see that line's getting a little more squiggly. Let's keep going down about neg 110. Same thing again. We're getting a weaker signal in. We're still getting about 20 dB worth of gain. However, we're getting more noise on that signal. Let's get down to about neg 120. And we're getting more noise on there. Now this is all to be expected. Let's go neg 125. Same thing. We're probably averaging somewhere around neg 20 or so. Or sorry, about 20 dB worth of gain. However, you can see we're getting a lot of noise. As I said, that's all to be assumed. Alright, now we're just having a little bit of fun. Everyone's always so concerned about running tons of different connectors and adapters and surge arresting and lightning protection and all that jazz. Well, here if we look, I got 1, 2, 3, 4, 5, 6, 7 different adapters. I've gone through and I've normalized this adapter, this cable, and this adapter. So the value that we're going to note on the screen is measuring this cable and all these adapters right here. And if you notice, we're right around 1.5 dB worth of loss through all these connectors and this cable at 905 megs. A dB and a half is absolutely nothing, and really nothing to be concerned about.